So hello, we'll do another question. Are you guys geared up for another question on LR and DI? You guys all feeling good? Let's do the question, right? I give you good amount of time. I give you about, let's say about 90 seconds to look at this question. 90 seconds. That's ample amount of time probably that you guys will get to review this question, right? 90 seconds. So that's pretty much almost good amount of time that you guys have got, right? A pretty interesting question on number, fitting in numbers from 1 to 16. Okay, let's see. Of course, I've not shown you the questions. The questions are like this, right? The integers which are to be placed. We have answer options, and you know what? And this is going to be the crux. This is what you will probably be using in the question. But even if this is not there, I really don't want to sum up the entire thing by saying, look at answer options always and do it. That's your last resort. But come what may, even without using answer options, you would be able to easily solve a question in 10 minutes in LRDI. Under 10 minutes, right? Shouldn't matter what difficulty level. Not happened in CAT till now, which can take more than 10 minutes. Not yet, right? So you really don't have to look at answer options, but come to the examination point of view, you will look at answer option. I'll come to what answer options we are talking about in a while, right? But first, let's look at the question and the way the question might be able to solve. The question says five of the positive integers from 1 to 16 have been placed. So we have 3, 14, 6, 12 and 7. That's nice. And 5 of them have been placed. That's good. In a 4 by 4 grid, the remaining positive integers from 1 to 16 are to be placed in the remaining squares of the grid subject to the condition. Right? So conditions, we can look at the next page. Right? It's pretty much here. No even number is placed in the first row. So we understand these are rows. That's the first row, second row, third row, and fourth row. These are the rows. We are talking about the rows. And we are talking about the columns, right? If we talk about the columns, this is the first column, this is the second column, this is the third column, and this is the fourth column, right? We have the columns here. Okay, so that's some amount of data, and let's see what next. Okay, so now no even number is placed in the first and fourth row. No even number is placed in the first and the fourth row. Okay, fine. That means all the even numbers are in the second and the third row. We all understand from 1 to 16. From 1 to 16, there are 8 even numbers, right? If you're talking of odd, there would be 8, and if you're talking of even, there would be 8. All the odd numbers are here. We only place odd numbers here. We only place odd numbers here, and the rest of the even numbers will come pretty much in the second row and the third row. No multiple of 5. No multiple of 5. We are looking at the point number B. No multiple of 5 is placed in the first and fourth column. Now it's column. It's changed to column. No multiple of 5. That means we're not going to place. What are the multiples of 5 we have here? 5, 10, and 15. We are not going to place. We are not going to place 5. We are not going to place 10. We are not going to place 15 in the first column. Nor are we going to do that 5, 10, and 15 in this column. Right? Now 5, 10, and 15, right? Out of the 2 are odd. Let's understand 2 of them are odd. So one of them, of the 2 odd numbers, right? One of them will come at the top row maybe, or both of them will come at the bottom row maybe, right? But 2 of them are being fitted here, and probably 10 will come, somewhere within these 3 blanks. But that's quite a number, right? 2 out of 3 is better than 1 out of 3, right? The sum of integers in one of the diagonals is 18. Okay, nice. That's quite some information. One of the diagonals. That means it could be this diagonal 18, or it could be this diagonal 18. The sum of the 4 numbers, right, would become 18. Right, would become 18. That's makes a lot of sense, right? It would become 18. Okay, good. So, which diagonal is 18? Only one of them would be 18. But let's understand the number 10, right? The number 10 would either fall in this diagonal, right? Let's say it falls in this diagonal, right? In this diagonal, that's 10 here, or it could fall in this diagonal. Right? If it is 10 here, also it will be on that diagonal. It could be 10 on this diagonal. If it's on the diagonal in which 6 is there, obviously this cannot be the diagonal on which we have 18. Right, because they're all distinct numbers. We already have a 6 plus 10. But if it falls in the other diagonal, right, then we'll have to check, right? But if it falls in the other diagonal, that diagonal cannot be 18 because we already would have had a 7 plus 10 and whatever 2 numbers, right? Whatever 2 numbers, right? So whichever diagonal has the 10, right? Whichever diagonal has the 10 cannot be the diagonal where the sum of integers is 18. Are we good with this data, right? So it just cannot work that way. It just cannot work that way. This is not happening, right? That's not a data that can work for us, right? One of the diagonals is 18. Whichever diagonal is 18 does not contain the number 10. That's for sure, right? No square or cube of an integer is to be placed in the third column, right? So what are the squares and cubes, right? What are the squares and cubes? We have like the numbers in question, the squares and cubes. So we have 1, that's 1 square, right? We have 4, that is 2 square. We have 9, that is 3 square. Okay, and we have 16, that is 4 square. We also cannot place a cube. That means we cannot place 8, right? And these 5 numbers cannot be placed, right? No square or cube of an integer is to be placed in the third column. So within this column, we cannot place these numbers 1, 4, right? 1, 4, 9, 16, and 8. Oh, that's quite some data, right? You cannot place these numbers 4, 16, and 8 here. You cannot place 1 or 9 here. That's quite some data. Okay, so we cannot place 1 and 9 here. We cannot place a 4. We cannot place a 8. We cannot place a 16 here, right? Also, we cannot place a 4. We cannot place a 8. We cannot place a 16 here. Quite a lot of data, guys. This is a very nice statement. The sum of integers in the column which contains 10 should not be less than the sum of integers in the column containing 1, right? So whichever column contains the 10, right? Whichever column contains the 10, right? Assuming, right? We know 10 has to be either in the second column or the third column. That's the problem. Why? Because we cannot have 5, 10, and 15 in the first and the fourth column. So if you're talking of 10 and 10 is in the sixth column, right? 10 is in the second column, the number having 6, then they should not be less than the sum of integers in the column containing 1. And we know we are yet to discover where would the number 1 be coming in, right? We are yet to discover that number, right? No more than one square of an integer is to be placed in any diagonal, right? We cannot place more than one square in a diagonal. Whichever diagonal you want to place, you cannot place more than one square in either of the diagonals, right? Okay, that's another good data. The sum of integers in the first row is equal to 30. Wow, now that's quite some information. The sum of integers in the first row is equal to 30. Right? Out of the 30, we have already removed 3. That means we are left with a total of 27 in the row number 1. We are left with a number total of 27 in the row that we are talking of, row number 1. And all the other numbers should be odd numbers. And within that, right, within the given odd numbers again, within the given odd numbers, right, we cannot place 7, right? We cannot place 7, right? We're going to want to make 30. So 23 plus 27 plus 3, that would be 30. We cannot place 7, right? And so we have 27 as a sum of those numbers that will be placed in the first row, right? We got to place, and another part, if you're talking, right? What could be the cases? Now we were finally coming up to a case where we can probably look at where to place these numbers. One thing is certain, right? That is coming back to the point number D. The point number D says that 4, 8 and 16 cannot come in the column number 3. That means automatically we have to have one among 4, 8 or 16 here, 4, 8 or 16 here, one among 4, 8 or 16 here, and the last 4, 8 or 16 here. Right? That means there are two even numbers left, namely 2 and 10, which automatically means this should be a 2 or a 10, while this should be a 10 or a 2, and there's no other possibility. We cannot even think of another possibility, right, beyond this. That means 10 is in the column number 3, and so is 2 in the column number 3. So we have two cases, right? If 10 is in the second row and the third column, right, in the second row, third column, then this diagonal total will not add up to 18, right? Total will not add up to 18 because 6 plus 10 is already 16. We cannot place a 1 and 1 kind of number. We don't have that, liberty, right? But if it is not, let's consider the case it is. If it is, then the other diagonal should become the total of something like 18. So let's assume for a minute that this is having 10. This diagonal has 10. That means this diagonal does not have 10. That automatically means this should have been a 2. This should have been a 10. So 7 plus 2, that is 9. 7 plus 2, that is 9. We need to have another 9. In total, we need to have a 9, right? To make it 9, you cannot place a 16, right? You cannot make a 16. We cannot put a 4 for the simple reason that if this is 4, this will become 5, but 5 cannot come in this column, so that will become 8, right? That will become 8, and this would become 1. Now there's no problem with the conditions, right? There's no problem with the condition. Also, we know, right, not more than one square is placed in that particular column. That's working fine. So this is 8, that is 1, right? And if you look at 6, 10, the other diagonal, that's fine, right? But we had a statement. All of you okay with this, right? All of you okay with this? Now we need to place, right? We need to place the number, some number along the other diagonal. And if you look the total, okay, we are also looking at another number, another interesting take here. 27, out of that we have already discounted 1, right? We have discounted 1, and we need the sum of other two numbers, right, as equal to 26. And the best thing is we are looking at two odd numbers, right? We're looking at two odd numbers here, right? So one, if he place a number like 5 as one odd number, right? So we are looking at putting 5, and if we place one number like 5, but the other number, the problem is, we'll end up placing a 21, which we don't have. We don't have the liberty of placing 21. That means the number in context should be 15. If that is true, this number has to be 15, right? This has to be 15. If it is 15, we already know he won 15 plus 3, that makes it a total of 19. It means this number should become 11, right? Now, are we getting things, right? Okay, I think that's neat, right? I think that's neat. We get 11 there, we get 11 there, and filling up this particular case, right? We get 11 there, okay, and okay, we get 11 to 6 and some other number. We need an odd number, which is we have already placed 15. We need to place 5 somewhere. Let's try to place the 5. It's either here or here. Okay, the 5 will definitely come in one of the two places, right? And we've already placed the 8 as per our observation. We've already placed the 8, and one statement that we have to look forward to in this particular case. So we've already filled this question. This part is done, right? I think we have put that 18, point number C. Multiple of 5, we still have one multiple of 5, that means 5 could either come here or here. We'll fit that in a while. This E statement is going to give us the head start here, or the final touches here. The sum of integers in the column which contains 10, right? The sum of integer which contains 10, that's the sum of integers of the column which contains 10, that's this column, right? That is 3 plus 10 plus 2, right? Plus some number, right? Should not be less than the sum of integers which contain the number 1. That's like column 3 cannot be less than column 1, right? Yeah, it's not saying it cannot be equal. It could very well be equal, but right now the total of column 3 is 15, right? The column 3 is 15, which goes on to say that already column 1 is 1 plus 4, which is 15, right? This means that column 1 cannot have 16, it has to become 4, and this number would become 16, right? That's pretty much fixed. So we have a 1, 14 and 4, right? That total now for us is 19 plus whatever number that's going to come here, some odd number for sure. It could be a 9, or it could be but it cannot be, it cannot be, it could be a 9, it could be a 9, right? It cannot be a 5 for sure. We know 5 is not allowed. We know, 5 is not allowed. 5 is either going to come here or here, right? Or it could be a 13, right? It could be also a 13, right? So we have three numbers left: 5, 9 and 13. 5 is out. 5 is out because we don't have 5, 10 and 15, or multiples of 5 are not there in the first column. Assuming that this were 13, right? Now this part cannot have that big a number, right? So we have, total 3 plus 2 plus 10, that makes it 15, 15 plus 9, but this becomes 19 plus 13, which automatically means, hey, listen, you know what? Let's put a 13 here. Let's put a 13 here, right? Which means if 13 is here, the other 5 should come here and the 9 should come here. There's no much to guess or no much to think here. So we have a 19 plus 9. Okay, so 19 plus 9, that makes it 28, and this column number 3 is also 28. 15 plus 13. Right, that fits in everything in place. Fits in everything in place. You can go through. You can also figure out that if you had done the reverse, that is 2 and 10, right? Instead of placing a 10 and 2, right? It wouldn't simply work. It wouldn't simply work, and it would go wrong for us. So let me just clear off the mess, and let's fit in only what is required, right? Only what is required for us in this particular case, right? Okay, so that is something pretty simple actually, right? Just look at it in the way it has to be done. Don't think of the complications, and these kind of questions should you be expecting in the exam? Well, I hope these type of questions do occur, right? I'm pretty hopeful that I hope that it occurs, because I think these are kind of things which make you think, right? And many people would not have solved a question like this in their mock, right? That gives you a head start in the examination, compared to somebody else. So I normally want these type of questions to turn up in the exam, right? It's not that because it's difficult, it's easy. Everyone will be able to do it, but then you get a head start just because not because you've done this question. You get a head start because you're thinking different, and that's important in the examination. You're thinking in a logical perspective, right? That will get you head start in everything that you do, not only in the exam but also in life. Okay. So yeah, I missed out on this number. So this number is of course 16, right? So that fills our table. So now we can answer the questions. There are 4 questions or something to answer. The integers which are placed in the remaining squares of the second row. So in the second row, the remaining numbers are in the second row. That is 8, 10, and 16. That's the last answer option, right? If you check the question 2, the integers which are placed in the remaining squares of the third row where I think 4 and 2. That's easy. 4 and 2, the integers that were placed in the remaining squares of the fourth row. That is 9, 5 and 13, 9, 5 and 13, and the integers that are placed in the remaining squares of the first row. That is, we got that as 15. We know one number, right? And we know 3, and we know 15, 15, 11, and 1. That's 15, 11, and 1. Now, yeah, I was talking of the answer options. Now, we know the total was 30. That means this is out of context because, this total plus 3, this plus 3 should give us 30. This will automatically be ruled out. This 11 plus 15, 11 plus 15, right? That's 20, 26, right? 26 plus 9 is more than 30. Now this itself should have been ruled out. You have only 2 cases, right? You have only 2 cases to even think of moving forward. So 11 plus 15 plus 1, which is 27, or 13 plus 9, that is 22 plus 5, which is 27. These are only 2 cases. So you should have started with one of the 2 cases and start building on it, right? That's primarily how you might have wanted to approach this question, right? You look at answer options and you could have made this question way simpler, though it's simple in any case, right? It shouldn't take time, right? So it's simpler otherwise as well, right? So that's a good question, right? Are we all okay? So we tried looking at the data. Okay, now many people, what they do is they look at the entire data at once. Like some people, I understand, they look at the reading comprehension also in this perspective. They read the entire logical reasoning caselet or a reading comprehension for once in a slow, in a fast manner, and then they come back, read it slow. I don't know if there is some merit in this particular method, right? Honestly, I feel it's the reverse. You do it first time itself. You start pushing in for the right data into the context and start working instead of going slow. For all you know, the question may be way too simple for you to go slow and then go fast, right? So like we did, as in when we moved with the questions, we started placing in the data and start working. That gives you a little better insight into how much time the question might take, and second, it would also give you time, right, to decide whether you want to skip the question right away or not, right? So there's two benefits of doing it at one go instead of, waiting for to finish one part and then pushing off to the other part, right? Okay, so that's good. That's pretty simple. Nice caselet. Shall we move? I think that's good. Good questions, right? Okay, all good. Thank you for listening, right? And hello, we go to a question on LR and DI. So for all of you, we have a question. That's a neat question. In my opinion, this is something very different. I'll give you about 90 seconds time to think of the question, right? This is what the question looks like, and this is the main idea of the question. And among the 3 students who has scored overall second highest marks, and then what is the ratio of the difference in the total marks scored by Amit and Kunal to the difference in total marks scored by Ravi and Kunal, and the marks scored by Ravi include 90 awarded to him on account of his excellent performance or something, right? We'll try to do this question, right? So I'll keep the first question. The data is pretty simple. I give about 90 seconds. Okay, that's about 90 seconds to probably look at the question and try solving it. That's about 90 seconds. So take your time. Okay, so we're almost there. We have about 10-15 seconds to go. Cool. So we'll do this question. Now, this is a chart which is slightly different. It's also known as a triangular percentage chart. Many of you would have been taking these some mock test series and so on. I'm guessing this is the type of question that very few of you would have attempted. In fact, I probably can. None of you would have attempted something like this. So that's the reason I've tried to incorporate a question like this to make more sense, right? Because you need to be aware of the changes that may come, right? Now, if you're looking at triangular charts, so tomorrow you might start looking at a pentagonal percentage chart, right? Anything can happen in the exam. So what's a triangular percentage chart? Let's first build on this word called a percentage chart, where your total addition of something would become a particular case would become 100%. That's a triangular chart. You'll see, you have a triangular chart where we can say, this is the expenses, right, and this is the savings. So let's say expenses is 80%, savings is 20%. The total will add up to your income, that's 100%. So that's what we mean by a percentage chart, and it's in the form of a triangle. So certainly a triangular percentage chart, right? That's how simple the thing marking should be. But this question has certain more elements. There are three parts, right? There is QA, right? QA, that's 200, evaluated out of 200. There is, RA, that's evaluated out of 300, and there is VA, that's evaluated out of 400. That's three parts. And there's just three guys, their names being Amit, Kunal, and Ravi. There are just three guys. Now, if you start, let's start with Amit. Now, you look at these, you look at these lines. These lines are giving you some indication of some movement, right? Which means if you look at Amit, and if you're talking of a QA score, all we have to do is drop down a line from here. Look at the direction of the QA. So parallel to that, you got to drop down here. So that fits in somewhere between 0 and 20. So let's say that's a ballpark figure, like approximately like 10%, right? That's like 10%, right? Which means it's 10% of 200, by the by, that would be like 20, right? But if you look at Amit's marks, if you look at Amit's mark in RA, look at the graph, look at where the graph is pointing towards RA. That would be RA for Amit. That would be like 80, bang 80%. So 80% of 300, that's like 240. And if you look at Amit for the third section, the third section the third section in context, right, is VA, and the VA graph is right at the top. It pushes here, right, parallel to this, right, parallel to this. It pushes here, right. So that makes it 10% of 400, which is 40. And the beautiful part is for Amit, this is 10, 80, and 10. That makes it 100%. So that's a percentage chart and a triangle, of course. Neat, right? This is something different. Likewise, let's quickly work with Kunal, right? So Kunal's QA is straightforward. Here, QA, that is 60%. I'll put the marks later, right? Kunal's RA, that's anywhere between 20 and 40. Let's put a figure of about 30%. And Kunal for VA, right? We'll have to push it again to the top. That will be like 10%. That makes it a total of 100%. Let's fix the values now. That's like 40, right? 30%. That'll be like 90 of 30% of 300 and 60% of 200. That's like 120. Let's look the same thing for Ravi. Now Ravi's score in RA would be pretty much here, right? That would be like same number that we are talking of 30%, right? Ravi score in QA, there will be somewhere here, which is not exactly in between 20 and 40, but somewhere there, right? Not the mid value, but somewhere somewhere there. It's about like, let's say 25%, that will be like 50. And if you look at the last particular part, that will be somewhere between 40 and 60, tending more towards 40, right? Tending more towards 40. And what is the score we are talking about 45%. Shall we say this? About 45%, so the total becomes 100. So we don't know the accurate values, but somewhere right there. Okay, so that makes it about 180. So we have the scores, we have everything. Now let's answer the question. Pretty simple, but the point is, by the look of it, I'm not sure how many of you might want to attempt. So it's not that just because it's new, it has to be tough. It is new, so it might be one of the two things, right? If it is new, it might be easy because these kind of caselets may not have been created. So for the first time, when the examiner will want to give these questions, he might not take a very tough one. Second, if it is new, right, it could be logical, and what better to have than a logical caselet, right? So that's pretty nice. So you never refrain from attempting these newer type of caselets. Never seen, unseen questions, unseen type of caselets, right? These are something that you must work. Now, if you're talking of CAT 2017, right, there were two easy caselets in your slot 2 with respect to frequency distribution. Now, frequency distribution has not been coming in CAT. In fact, it's so rare in CAT, and that type of frequency distribution made it look so different. But trust me on this, right? That's an easy case. We'll do that in probably in some class, right? Just to get a heads up on that. That's so simple and so nice that you'd want to get a hang of that as well, right? Okay, so we have all of it, right? And now I think we should answer the question. Among the three students, Amit, Kunal and Ravi, who has scored the second highest marks. So if you want to tally the marks, so Amit's marks right now is 22, 40 and 40. That makes it 300 for Amit. Congratulations, Amit. 300 out of 900. If you look at Kunal, that is 120, 90, 210 plus 40. That's 250. Kunal, you're not doing as good as Amit. And if you look at Ravi has 50 and 90, that makes it a 140, and 180, that's a 320. Good work, Ravi. You are leading among the three, right? So who has scored the overall second highest? That is the question, not the highest. So it's pretty simple. Second highest would be Amit. We'll keep this data for the next question. Let's look at the next question. What is the ratio of the difference in the total marks scored by Amit and Kunal to the difference of the total marks scored by Ravi and Kunal? So Amit and Kunal, the difference being about 50. So Amit and Kunal, the difference being 50, right? And if you look at the next thing, right? Ravi, right? They're talking of Ravi and Kunal. So Ravi and Kunal, the difference being like 70. Ravi and Kunal, that's 70. Well, let's also discuss this word difference. So in CAT, when you're talking of this word difference, it normally means the higher value minus the low value. It normally means that. It could be used other way, right? Difference meaning first and second, but normally it would mean higher value and low value minus the low value. Subtract higher value from the low value. It does not matter which is first or which is second. High minus low, that is what normally means difference. So we are talking of the ratio here, right? So that's simple. That's 5:7, right? And the third question, right? The marks scored by Ravi include 90 awarded to him on account of his excellent performance in sports. 90 marks are distributed among the various sections as additional marks apart from what Ravi scored in the three sections. What is the approximate percentage of the section marks scored by Amit in QA to the total marks scored by all the three in the same section? So Amit in QA. What does Amit have in QA? That's 20. Amit in QA. That's 20. So the total marks scored by all the three. Now we also have Ravi, who's got additional 90 marks, right? That's distributed, right? So currently the total marks of in QA for all the three, that's about 100 and 20, that's 190, right? We're looking at a 190 plus the marks that Ravi got additionally, right? Additionally in QA, right? So do we know the marks additionally that we got in QA? It says these marks were distributed, but was it distributed equally? Right? If you look at this particular table that we drew, were these marks distributed equally? Of course, we have no idea, we have no clarity. Was it equal distribution or unequal distribution? If it is equal, that is nice. There would have been a 30, 30, 30. If it is unequal and they set the proportion, We could have worked with it, but they've not mentioned anything like that, right? Which means this value can be anything from 0 to 90. So we have a range of answers. That's why the answer should have been, right, indeterminable or something. We don't really want to find out the answer, right? Okay, so that makes sense. Let's look at the question again, right? This is what the question was. Triangular percentage, right? A triangular percentage chart. So that made it a little nicer, right? A little more refreshing than some questions which don't have this, right? In particular, this reminds me of a CAT 2017 case here, right? This reminds me of the frequency distribution. You must check. You guys must check that case slate, right? If you get time, I'll also try to do it, but you must get. So that's like driving a new thing, altogether new thing, but people who attempted and who were smart enough in choosing that question and understood what the frequency distribution ended up finishing the question. In this question, people all they had to understand is the three lines, and they would have done with the question pretty neat, right? Okay, so that's simple one. That's nice. Good take on the caselet, right? Good take. Let's take another one, caselet, right? That's a beautiful one. Let's look at the questions first. Okay, let's look at the questions. How does the question look? Is the question which the following pair was definitely chosen for somebody, right? For which of the following persons can the size of shoes be determined, and which of the following additional statements are required? Correctly identify them, right? It's a very important caselet for me, right? I'll explain this, but just go through it. I'll give you about 90 seconds, okay? 90 seconds to start.
Press the bell icon on the YouTube app and never miss another update.
Alright, so beautiful caselet, right? Many a times, guys, many a times you must have noticed that I keep talking of this rule called a sliding rule, right? This is an interesting rule, right? That can be used in several types of questions. It's not particularly a rule or something. It's a method that we use in several questions, the sliding rule, right? Let's pick that for this question as well, right? The sliding rule is something that works beautifully, right? So let's quickly read, and then we'll assimilate the data and work on this, right? This makes this question a unique type of question. Though this has math in it, it has math because of the average part. But this is one question which takes a mathematical reasoning to heights of logic, right? Very beautiful, simple one if someone has understood something called the sliding rule, right? That's all. And this is not the first time I'm doing sliding rule. I think this is the fourth time or the fifth time that I'm using. In fact, we'll be using this rule in a couple of more questions. You'll notice that, right? And give or take, if you talk over the last few years itself, this rule has been used in the exam. Though there could be other rules, other methods that people can come up with, but this method has worked wonders for my students solving some questions. So let's look at this question. Okay, so there are these five, there are these six of them: A, B, C, D, E, and F, right? Shoe manufacturing company. The sizes of these six people are 6, 7, 8, 9, 10, and 11. A person cannot be gifted a pair whose size is in the range, can be gifted in the range plus minus 1. That means someone's shoe size is 6. The person can be gifted a 5 or 6 or a 7. So A can wear 5, A can wear a 6, A can wear a 7. Likewise, F can wear a 10, F can wear 11, F can wear a 12. Right? The shoe can be gifted. All that is there. It was found that 3 persons got pairs of one size, right? 2 persons got pair of a different size, and the remaining person got a pair of the third size, which means very important data. Okay, 3 persons got XXX size, whatever the size, it does not matter. 2 persons got Y, and a third person got a Z. It has to be of this format because let's read it again. It was found that 3 persons got pair of one size. 3 of them. Who? ABC, we don't know. 2 others got pairs of a different size. That means Y and Y. And the remaining person got a third size, that's Z. Are we getting this? Now this is the crux. The entire story will work around this, and then the sliding rule will come into perspective. The average of the shoe size of the 6 people is 0.33 more than the average size of the 6 pairs gifted to them. That means gifted to them is 0.33 lesser, right? So let's bring it in a particular sheet. So we have the people names are A, who should get shoe size 6, B, who should get a shoe size 7, C, we should get a shoe size 8, D, who should get a shoe size 9, E, who should get a shoe size 10, and F, who should get a shoe size of 11. Right? This is their actual shoe sizes. This is what is given information, right? This is their given information. This is what they should possibly get. But we all understand it could be a plus minus. It could very well be a plus minus 1. That's what is mentioned in this case. It could well be a plus or minus 1 in this particular question. So let's start. We know that we must have of the format anywhere. It does not matter where it is, right? Now just think of it. Just think of it. Okay, I'll retrace the path here. We can possibly put an XXX here. We can put a Y and Y here, or we can put a Z here, right? Come to think of it, the slide is this. If we can put a XXX, we cannot put a YZY, right? That we will try to explain in the next couple of minutes, and that's why this XXX, YY, and ZZ is so beautiful. Right? What I mean to say, let's try to explain, right? First of all, the total of the shoe sizes, the 6 shoe sizes, 6, 7, 8, 9, 10, 11, the total actually happens to be the number 51, right? The total. But the shoe sizes of these guys, the average, if we take 51 divided by 6, that happens to be 8.5, but the average is 0.33 less. That means the total, when average now becomes 8.1666 or 17, that means the total would become 49. 49 by 6 would become, right, a total of, average of 8.17, which means the total of the shoe sizes of these 6 people should be 49, which also means that we must drop shoe size of some people. Otherwise, it's not going to function. Let's see, okay. So can I put somebody having a 6 year and a 6 year and a 6 year? That's not allowed, right? Because you can have a plus minus 1, right? Can we have can we have a 6 here and, probably let's try this, okay, just to get you a hand on this, right? Let's say someone has a 6 here, right? A has a 6, A has a 6, B has a 6, and D has a 6. Can that work? You'll notice that that will also not work, right? Because D will become quite a lot, more, right? We cannot have, right? But if you look, can we even have a 666? The only way this can accommodate, the only way we can have an XXX, right? Only way we can have an XXX type of case is assuming that assuming that, the middle person is taking the value and not others. That means this should become a 777, right? Or we could have probably have 888. Come to think of it, right? We can have 888, or we can probably think of having, right, 9, 9, and 9, or we can probably think of having, right, uh, 10, 10, and 10. You just wonder. Otherwise, you just cannot do anything. There's no way I can have a 666, right? I mean, ABC cannot be a 666 because C will, XXX will, see, you look at the slide. Look at the slide, from top it's going down. This is called the sliding rule. It keeps moving. It keeps moving from one end to another end. Interesting rule, and it works. The beautiful thing is that there are questions based on this that has occurred in the exam. We've already discussed this several times, right? Okay, now let's look at the Y and Y. But before that, if you look, A plus B plus C, total shoe size is 17, and total shoe size is 21, 7 into 3. But actual shoe size, if you take this case, the case number 1, this is also 21. That means my actual total, which was 51, should now drop to 49, has not dropped. Are we getting this data, right? It should have dropped to 49, right? But we have not even dropped by 1. That means the drop of 1 should happen between the Y and Z. Of course, the drop of 2 cannot happen in Z. Only 1 can happen in Z, because if someone is, let's say, 11, it cannot become 9, right? It can have a drop of maximum plus minus 1, which means that Y and Y should have a drop. So let's look now. Can I make this person like D as 9 and E as 9? So we have 9 plus 10, that is 19. But now for D and E, the actual values are 9 plus 9, 18. There's already a drop of 1, right? Which means F, if we drop 1, the shoe size of F, instead of 11, we make it 10. We have a magic case. 7, 7, 9, 9, 10. Now, why am I talking about the sliding rule? I have noticed this, okay? I've taken this particular case probably 100 times, but I've noticed people only work on one such solution and move ahead, right? Thinking that that's right. That means the XXX, YY, and Z should be right, right? People who have come that far. But the point is, look at the slide. There is a BCD also having the same sizes, XXX, or a CDE also having the same size, XXX, or a DEF also having the same size, XXX. And we are not even done, right? But you notice this Y and Y can only work together. The XXX will always work together, and Z will be independent, which means, can we have another case? That means case number 2 with a 777, and instead of D being 9, we can make it D as 8, and automatically E and F both becoming 10, right? Within the slide, we have an interchange. So that's the add-on, right? Just not a sliding rule that we talk. And sliding rule, guys, is pretty important for IIFT, right? For this exam, is pretty important. Okay, let's look at the point number 3. Case number 3. So we have a 8. So there is only one thing. That's a Z has to come here, and the Y and Y has to come here. Are you guys getting it? Y, XXX has to be together, right? Because if you don't have them together, the values will increase, and if the values keep increasing drastically, the total from 51 will not come down to 49 from the shoe sizes which was required vis-a-vis the actual shoe sizes that they wore, right? Which means now, if you're talking of A, this was 6, this has to reduce, otherwise my total, because 8 plus 8 plus 8 for B, C and D is 7, 8, 9, total is 24, and 8 plus 8 plus 8 actual shoe size is also 24. There's no fall in number, that means my 51 will remain 51. You want to bring it down to 49. The reduction of 2 will only happen if A reduces by 1. Instead of 6, that number should become 5, and E and F together should reduce 1. If we could try reducing 2, I would have been very happy. We cannot, right? So that means these two numbers should be 10 and 10. That's the only way to go ahead, right? We'll take the case number 4. We don't have an interchange here, right? So case number 4. So A and B should now be the Y and Y case, and F should be the Z case. So let's look at what we can put, right? So Z is easy. It should reduce by 1. That means instead of 11, it should become 10. And A and B should totally reduce by 1. That means A is already 6, B is already 7, so total is 13, it should become 12. The best practice here for us would be to place a 6 and 6, right? And we have another case, that's a case number 5. We have a 10, 10, 10 for D, E and F. The total is 9, 10, 11, that is 30, and 10, 10, 10. Actual shoe size is also 30. Now we can place a Y and Z. So let's say if this were 6 and this were 6, and C value instead of 8 could become a 7, right? And again, you'll notice that there could be an interchange here. Right? The interchange could happen with 6 or the last case. That means A could become a 5 and B and C could each become 7 and 7, and you will check in each case the total in each case of these is 49. 49 because you wanted the average as 0.33 less than your original average. Total was 51, that is 6 plus 7 plus 8 plus 9 plus 10 plus 11, right? The average being 8.5, average has to fall down by 0.33, that means 8.17, and it works, right? It works beautiful, right? It works beautifully, right, for our case, right? Okay, superb. The sliding rule, the question does not end at the sliding part. That's what I like in this question. It is beyond the slide. So it's talking about the slide, but beyond the slide there was an interchange. That means we are not only talking of x, 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 y, z. We can talk of x, 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 y, y, z, and x, 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 z, y, y. There are two possibilities, right? X, 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 z, y, y, and x, 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 right? X, 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 Y, Y, Z, but not in all cases, in only two cases, at the start and at the end, right? That's where the limits open up. The rest, it's working beautifully, right? That gives us only 6 cases. Now just imagine, what if I give you 10 people, right? Now the slides become even more interesting, right? And it works beautifully, right? If I do get time, I definitely want to do for 10, right? Instead of just doing 6, and it still works beautifully for 10. Or any such number that it works. We've already done a case for 4, right? Before. So this is a case for 6. Probably we'll graduate to 10 someday, right? That makes this question really interesting, really beautiful. The sliding rule plus a little bit of logic, right? So there is math. There is in math there is averages. There is how averages gets affected. There is the sliding rule, and then there is a little bit of thinking beyond the sliding rule. There's a little thing that you have to work, that is, it's just not x, 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 y, y, z. It could be x, 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 z, y, y. That means there could be interchanges. All in all, summed up, I think this is a beautiful case to work with. It gives you a lot of perspective on your thinking, right? And yes, after all, not very difficult. Trust me on this, right? This question should not take more than 4 or 5 minutes to solve, as long as you understood the slide, right? And thereafter it's very easy, which is the following person was definitely not gifted the pair whose size was different from the rest of them. That means who definitely did not get a unique pair, right? This is the following. This person has always got a pair with somebody else, right? Now if you look at A has a unique value here and here, right? What about B? B is always, right? You'll notice B is always staging with somebody else, right? B never has a unique pair. For example, here in the first case, B has the same pair as A and C have. B in the second case, B has the same pair as A have. In the third case, B has the same pair size as C and D. In the fourth case, B has the same 6 with A. In the fifth case, B has the same 6 with A. In the sixth case, B has the same size with along with C. That means they share. So B is the one who definitely is not necessarily having unique size. A can have a unique size. What about C? Just look at C. C can have a unique size. C can have the size number 7. C can have the size number 7. That's unique in the case number 5, right? C can have the size number 7. That's pretty much unique for us, right? Right? If you take D, D, does D have a unique size? Yes, it does. In the case number 2, size number 8, right? D does have a unique size. If you check E again, now E again the same problem. E is always matching with somebody. In the first case, D and E same size. In the second case, E and F same size. In the third case, E and F same size. In the fourth case, C, D and E same size, that is 9. In the fifth case, D, E and F 10. In the sixth case, D, E and F 10, all same size. So E also need not have the same, will necessarily not have a unique size, right? What about F? F can have in the first case, F can have in the fourth case, and so on. Right? So which person does not? But you look at the answer. We have both E and B, but then they have not given the answer option, any answer option with E, so it's certainly B. Which of the following persons can the size of the pair of shoes gifted to him be determined? Now you'll notice, is there somebody whose shoe size is not changing? That is F for us. So F shoe size is consistently 10, right? Pretty big shoe size for all you know, right? Okay, so that's the first one was B. This one is F. Which of the following additional statements are required to correctly identify the size of pairs of shoes gifted to each of the 6 people? Now the point in this question is nice that we have an answer option which says 2 only. We don't have an answer option which says 1, and we have an answer option which says 2 only. We would like to start with that, right, and not start with something else. I would not say 1 and 2 first. I would want to do 2 first and then check. So if I take statement 2, right, what does statement 2 say? Right, statement 2 says B is gifted size number 8. If B is gifted size number 8, there's just one case for us. Beautiful, right? We've got the answer. But then there's an answer option. There's an answer option which says, right, either 2 alone or 1 and 3 together. Now we'll have to check 1 and 3 together as well. So what is 1? A is gifted 6 and C is gifted 7. And we negate the statement. So A is gifted 6. So A is gifted 6. That could be case number 4 and case number 5. A is gifted 6. And the next statement says C is gifted pair number 7. So if C is gifted pair number 7, among the case 4 and case 5, C is gifted pair number 7. This case number 4 gets negated. We come only to the case number 5, with which we can identify the exact shoe sizes for everybody in the group. Right? That means we can answer this question. Well, we can answer this question using, either 2 alone or 1 and 3 together. Right? Beautiful caselet. We will do more on the sliding rule. Right? I hope you enjoyed this caselet. Right? I hope you enjoy LR. Right? I have fun taking LR classes. Right? It's an online mode, and trust me, if anything that you see that you're finding a little tricky, right? Go through it. Okay, it's something that before signing off, I would like to tell you, right?
You can learn any subject, anywhere, any place and on the go. Come, let us go the other way in learning. Download our revolutionary app for free.